Hi, welcome to time complexity upper bound calculation. Here we are going to find the running time for given constant function f of n 8012. For that we should use c and initial value of n0 such that 0 less than or equal to given function f of n less than or equal to c into g of n. Here the upper bound will be calculated by using the big O of big O of n, the right. So for that the given function is 0 less than or equal to f of n less than or equal to c into g of n. So from here c and n0 always positive numbers. The given function is substituted in the form of f of n less than or equal to c into g of n. So the given figure shows f of n should be always less than or equal to c into g of n after n0 onwards, from the n0 onwards. So n0 is the initial value. From the n0 onwards the f of n is always less than or equal to c into g of n. So the f of n is 8012, then c is still we didn't have, so that is the constant. Already we know the given value is constant, so c equal to c 8012. So when onwards we will get 8012 less than or equal to 8012. So now we will start from the initial value n0 equal to 1. So now from here 1 we will substitute, we will get the 8012 which is true, which is satisfies the given of function criteria f of n less than or equal to c into g of n. So the constant value c is 8012 and g of n is 1. So here always g of n will be 1. So suppose if you want to substitute the value greater than 8012, because this constant value here always should be greater than, multiply with c into g of n, right. So that should be always greater than to 8012. This is the given f of n. So now I am substituting the 9500. Yes, it is always greater than the 8012. So like that, when we are substituting the 11500, yes, 8012 is always less than or equal to 11500. So here the f of n is, since f of n is the constant, it is not at all depending on the input size n. So from here n0 will be 1. So for each and every value based upon the constant and n0, we can find out the value for c and n0. And in the example 2, we will find out the upper bound for given linear function f of n equal to 4n plus 5. So as per given big O of n, 0 less than or equal to f of n less than or equal to c into g of n for all input size n which is greater than the smallest input size n0. So we have to compute the c and n0 which is always positive values greater than 0. So given f of n is 4n plus 5, then c into g of n, you look at that here, this right hand side, this always greater than or equal to 4n plus 5. This is f of n. So here the dominating term is the 4n. The dominating term is n. The dominating term is n. So we will take that n term, and so here this should be always greater than the given function. So when we are taking the values, so here the dominating term will be taken, and the coefficient of this f of n terms, coefficient of terms which are in the f of n we have to take, right, because which is always greater than the given f of n. So here the dominating term n is considered and the coefficient of this f of n will be taken, and here the coefficient of n is 4 and coefficient of this constant is 5. We are taking that 4 and 5, and we will take the dominating term, then we will add it up, so we are getting 9n. So this is the 0 less than or equal to f of n, and less than or equal to c into g of n, so when it is c into g of n, c equal to 9 and g of n is n. So that's what given here. So here when you are substituting the initial value from n0 equal to 1, so when you are substituting the 1, it will be 1, and this is also 1. So 4 plus 5, it is 9, less than or equal to 9. Then when you are substituting the 2, n equal to 2, so it will be 8 plus 5 less than or equal to 9 into 2, 18. So if 13 less than or equal to 18, this is also true. So from n0 equal to 1 onwards, the condition satisfies f of n less than or equal to c into g of n. So this is the procedure to calculate the upper bound by using the big O of n. Thanks for watching.